Okay, come back. We have DC to AC conversion, that is called as an inverter. Okay, so what is happening? We are having the input DC voltage and we need to get back the AC. How exactly it's going to work? During the positive off cycle, first, it's not the positive, first cycle. When I switch on this, assume I am applying the IP current here, I am going to apply the IP current here. And I am going to measure the output voltage across the load. I am going to measure the output voltage across the load. What is my input? Input is DC. Correct? My input is DC only. Constantly I am giving the 30 volts. Assume 30 volts I am giving voltage. When I am switching on both battery 1 and battery 2, this will be working as a means I am applying base voltage, base current here. I am applying base current here. And these base currents are 0, base current of the both transistors also 0. So this is open loop, this is open loop. This is base current is applied, closed loop, base current is applied, closed loop. It works as a switch, this also works as a closed switch. So your power will move like this, your voltage come like this. Because it's open loop here, cannot enter here. Go here, this also open loop, cannot enter. Then come in this area. What happened? We are able to measure the voltage across the load because it is passing through the load. So during the IP, that is V1 and V2 is on. When the V1 and V2 is on, when your BJT1 and BJT2 is on, the voltage flows like this. We are able to measure the voltage across the load. Assume this is positive and this is negative. Actually, there will be no positive negative for the load. But for the current scenario, I am assuming that one, this is the positive and this is the negative. Now measure the voltage when V1 and V2 is on. V1 and V2 is on. Up to some time there is no, all the batteries are low, all the BJTs are low. After some time I switch on V1 and V2. So my output will be V1, V2. T1 to T2 I switch on both the BJTs up to T1 and T2. Then after T2 I switch off. This I am not applying base current for both the transistors. After that, at T2 and T3, I will switch off these two. I will switch on these two. Okay? You can have some more time also, delay also, no issue. Some more delay also will be happening. At T3 to T4, I will be switching on this and this. Now what happens? Your current flow is going to be in a different direction. The flow of the current is in different direction. Comes in this direction only, go here, go to B3, then go in the opposite direction, go to B4 and go like this. So here, negative to positive, the reverse direction is going to flow. Previously it was positive to negative, now it's in the reverse direction is going further. That means I will be having a negative voltage across this. Previously it was positive voltage, now it is negative voltage. Because the flow of the current is in opposite direction. Previously the flow of the current is from positive to negative, now the flow of the current is in opposite direction because V1 is off and V2 is off. Only V3 and V4 are on. It's going to flow in this direction. Since it is flowing from negative to positive, we are going to have the opposite direction. So what happens? My input is DC, constant value, but my output is alternate current I am getting over. Positive, negative. Similarly, if you do the process continuously, the process switch on these two once again, switch off these two once again, you will be having one more. So when you put them continuously at a high speed, you will be getting the alternate current over there. Getting? This is how your UPS is working in your home. Inverters are working in your home. Okay, my battery is also working like that only. Whenever the power is there, continuously through the power only it's working over there. When the power is not given, the battery has been connected through the battery. Whatever the charging is there, is going to get discharged over there. See, I will be removing this. I remove. Okay, till now it was using my AC power supply. Okay, directly from here. Now what is happening? Through the battery, it's working over there. Battery, what it is doing? It is converting whatever is required, it's going to convert that. Any doubts? How AC, DC to AC is going to get converted? DC to AC. The circuit diagram is very, very important. Okay. Two transistors are functioning here in one cycle, just like your bridge rectifier. Right? You have come across the bridge rectifier, no full wave rectifier, bridge rectifier you have studied. In bridge rectifier, two diodes are they're working during positive half cycle. During negative half cycle, other two diodes are going to work over there. So similarly, two transistors are working here, other two transistors will be working in the opposite direction. Uninterrupted power supply is the one of the example. Aircraft and space power supplies. I told you long back, space. Whatever the sunlight falls on your solar panels, they are going to get charged and it will be charging the batteries, and batteries are supplying the power to your, because whatever is there in the satellite, they need AC power supply. They need AC power supply. Charges stores in the DC, and DC will be converted once again to AC itself. Next, induction and synchronous motor drives, high voltage DC transmission system, induction heating supplies. These are the examples of your DC to AC conversion. Next two types, cycloconverters, that is AC to AC with variable frequency. AC to AC with variable frequency is a cycloconverters, we'll call that one. AC to DC, DC to DC, DC to AC, we have finished. Now AC to AC, we are having analog current, some 230 volts, but that need to be converted into some variable current, but reduced one. Example is a fan regulator. A fan regulator, will call that one. We need a fan regulator, 230 volts is coming over there, but 230 volts is not required for me. I need to reduce that one to the required current, either increase or decrease. The regulator, as the resistance increases, your current flow decreases. As the resistance decreases, current flow increases. See here, regulator now, you will have 1, 2, 3, 4, 5, like this will be having over there. Correct? And this is 0. Or maybe off. Maybe off. When you put off means resistance is very, very high. That's why there is no current flow. When the resistance is very, very high, infinity, current will not flow. Now knob is rotated here. So resistance is reduced, maybe 10K. 10 kilo ohm. Flow of current is, previously it was that is no flow, no current was flowing over there. Now I have reduced to 10K, so some amount of current is flowing over there. So some amount of current is flowing, so your regular this one fan will rotate at low speed itself. Now what I will do, I'll put the regulator to 0.2. When you put the regulator to 0.2, instead of 10 kilo ohm, it's going to reduce to 5 kilo ohm. Means resistance is still reduced. Since the resistance is still reduced, current flow increases. Flow of the current increases. It's inversely proportional. Correct? As the resistance increases, current flow decreases. As the resistance decreases, current flow increases over there. So when I put it at the final stage, maybe I may be having some around 500 ohm. Just assume. I don't know what exactly is there. Design. Different regulators, they are designed in different values. So if it is 500 ohm or 100 ohm, current flows with a high speed. More current will flow into that place. So it is just inversely proportional. At the lower end, resistance is very high. At the higher end, resistance is very low itself. As you keep it high, as you keep it for 0.5, resistance is very, very low. Current flows, so your regulator, your fan will work with a high speed over there. So these circuits converts input power at one frequency to output power at different frequencies. That is cycloconverter. The name itself is telling cycloconverter. Means the cycles are changing. Frequency means cycles. You may be having 100 frequencies, 100 pulses per second, 1000 pulses per second. It's like this. This is cycle. One cycle, or how many cycles we have per second we are going to calculate. If the cycles are different, these are the cycles. Yellow color cycles are less, your purple color cycles are more. So cycles are getting converted. That is AC to AC. AC drive like rotary twin multi microwave AC motor drives. And the last one is AC regulators. I explained about the regulators, how exactly the regulators are working. What are the fan regulators we are having? These are the examples for AC to AC regulator. Cycloconverters is frequency changing. The fourth one. Fifth one is regulators, what we are going to have that one. So that's all for today. Let me stop my recording.